All right. So number one, I thought was kind of a tough one. So a decorative fence surrounds a rectangular flower garden. It is 2 yards long and 3 yards wide. You know what? I might have missed this one. All right. So that makes 6 square yards is the area. All right, so the area of the garden is increased by 20%. And so to increase something by 20%, I think the quickest way to do that is to take that 6 and multiply it by 1.2. So to increase by 20% is 1.2, by 50% it'd be 1.5, by, I don't know, 75% it'd be 1.25 is what you would multiply by. And that's going to give you 7.2. So that's what we want our new oh, maybe it's just worded bad. Okay, that's what we want our new fence. That's the area we want. So if the width remains the same, yeah, I definitely did this wrong. So the width is 3, the width is going to stay 3, and the length is going to change. All right, so we need to figure out what that new length needs to be by taking 7.2 and dividing it by 3, and that's going to give you 2.4. Now, if you mess up like I did and leave 2 the same and then change the 3, it would have been 3.6, but don't do it. That was wrong. I didn't read very closely. All right, let's look at Bailey and Kyla and, or maybe Kayla and Antoine. So Bailey, let's call her B, is twice as old as Kyla. And then Antoine, we'll call A, is 9 years older than Kyla. Antoine is also 3 years older than Bailey. And the question is, how old is Antoine? Okay, so this is a system of equations that's kind of different. What I did is I took what Bailey is, 2C, and I put it in there. And sometimes when I do these problems, I get all algebra-like, and sometimes there might be an easier way to do it. But since B is 2C, I just took that and I put it there. And then both of these, this and this, equals Antoine. So what I did next is I set those equal to each other. And then I solved that for C. That is not going to be the answer to the question though. But when I solved for C, I got my C's together. I'm going to move the 3 over. So C is 6. Kayla or Kala is 6 years old, which is an answer choice. That is not the answer. We want to know how old Antoine is. So I would take that C and put it in for C, and that's going to be 12 plus 3, which is 15 years old. Does somebody do that a different way that was way faster? Oh. Well, Antoine is the oldest, so maybe you could be like, okay, I'm going to pick the biggest number. Okay.
Not guess, but like I figured, if this person was older.
Just use some different ages.
Yeah.
That's smart. All right. Well, that's how you do it algebraically, but a lot of times, sometimes with questions like that, just logicking through it is easier. Okay, let's look at 3. So, what is an expression in terms of n for this sequence a sub n defined by the input-output table? So, we need to look at what's happening on the sequence. So, what is happening on the sequence? We're adding 5. Good. So on sequences, when you're adding 5 each time, that 5 is going to be in front of the n, like the coefficient. And there's only one choice that has that. And so that's what I did whenever I was going through, that I knew that the 5, it would be 5n. You could also like take these sequences, plug one in. If you plug one in, you should get 21, and plug two and you get 26, and just check it that way. But that one should be D. All right, let's look at science experiment. Okay, so we have a chemist boils a liquid, sets it on a table, and records the temperature as it cools. So we have these 4 equations, and we want to know which one matches. So it's definitely, they're all exponential, so that doesn't help. What I did is I just kind of like, I looked at 5, I plugged 5 in. I think there might have been 2-ish that were close. And then I plug 10 in. Like, so when you plug 5 in, you get something close to 40. When you plug 10 in, you get something close to 20. And it stays close to 20 for a very long time, which is going to end up being C. Okay. So 4 students rewrote this equation in factored form and found the zeros. Which solution correctly shows the function in factored form and identifies the zeros? So if we actually wanted to factor it out, the first thing you would do is factor out a common factor. Okay. And then, oh, this one, the way we learned to do it was slide divide bottoms up. And so you would slide that 2 over with the 5. And then find what multiplies to get 10 and subtracts to get 9, which is going to be 10 and 1. And then go back and divide by that 2. All right, that gives us 2 possibilities. And then the zeros are whenever you take those and set them equal to 0. All right, so that's going to be D. Now I'm going to show you another way to do it just by checking the zeros. Definitely going to be easier just to look at the graph. Why did none of my X's? Something is wrong. I don't. You can run to the restroom real quick. I'm going to try to figure out this calculator.
Okay.
What's happening? Okay, so the zeros are where it crosses the x-axis. So this one has 2. It has one there and it has one there. And so if you're looking at the answer choices, it's definitely -5 for that one. And then the other one is between 1 and 0. which is going to be the positive 0.5. So it's way easier to just look at the calculator, pick out which one has the zeros that match, 1/2 and -5. All right, number 6, you can do a couple of different ways. You can do it the long way by factoring it and canceling, or you can do the equivalent expressions that we talked about right before you guys took this yesterday. So if you do it the long way, this is what you would do, and then that matches up with B. If you do equivalent expressions, store a number for X, get a goal number, and then see which one of those also gives you the goal, which happens to be B. All right. Number 7 was the one I was talking about that's like really difficult to do the algebraic way. And so I would just do the equivalent expressions with the calculator. So I would store a number like 3. 3 is a good one for X. And type in 10 raised to the X minus 1. And so 999 is our goal number. And then just type in those answer choices, and whichever one gives you 999 is the answer. Okay, so A doesn't work. I don't really want to type them all in. I'm pretty sure D is the one that works. Yep. So we're looking for 999. D gave us 999, so it is it. Okay, and then for 8, we want to know which system has one equation. I would type them both in y equals, so one in y1, one in y2, and you're looking for something like that, where they cross only at one point, which ends up being A. So number 9, I would do this as a calculator question too. I would just take 27 and I would raise it to the 4/3, and you're going to get 81. So any of these other numbers that give you 81 is an answer choice. So when you do 4 raised to the 3rd, that's going to be 64. So that's not true. However, when you type B in, it does give you 81. When you type C in, it gives you some ugly decimal. That means the 4th root of 3, which is really small number, that gives you 1.316. So that's not it. 81 is 81. You guys remember how to do cube root? Not 4, good. So, yeah, sure. That gives you 81. And I would love for you to know why, like to be able to do that without the calculator, because it could be on the non-calculator later part. So whenever you do a fraction exponent, whatever is the denominator is the type of root, and whatever is the numerator is the power.
How am I supposed to figure that out?
It was a rule. We learned it. Well, the other ones, yeah, the other ones would be pretty tough. This right here, if you multiply these exponents. So if you multiply that, you get 4/3.
How are you supposed to do a 4/3 like in a? You know what I mean?
To do it without a calculator, you'd have to understand what it meant. and you do the cube root of 27, which is 3, and then raise that to the fourth and be 81. I think the only thing that would actually be on the non-calculator part would be getting an answer like just the E part. Being able to go from here to here. Not getting the 81, just knowing that I have a bunch of stuff written here. Just knowing that an exponent that's a fraction means it's a root. Whatever that denominator is the type of root. And whatever this is a power. So if you can remember that, that's what would be on the non-calculator. You can do that. And so like if you had 7 to the 2/5, what type of root is that? The fifth root or the square root? The fifth root of 7 squared. That's what you would need to know. Okay, let's keep going. We have a lot of time today. So for number 10, since the population P of Johnstown over a period of T years is, or since the town was founded, is estimated to be that formula, approximate how many years after the town's founding will the population reach 11,200 years? So I'd probably, if it was me, I think this is how I did it actually, is take those choices and put them in for T and see which one gives you the.
So when you do put it in for T, you have to put the E there as well.
You do. So to get E, let me get this 56,000. E is second, and then ln. All right, and then I'll put in 34 for the T. Got to do it right. Right, so that's way too big. And then you don't have to retype everything. You can just go up and choose it. And then type in 17 over the 34. Still too big. And then one more time, or two more times, depending what the answer is. There it is. That's definitely the closest. It's not exactly, but it's the closest. All right, let's look at 11. A craft store sells wooden boxes shaped like rectangular prisms. They come in heights from 5 to 10 inches. The table represents a function f of x, which gives the volume of a box with as a function of the height. Now, which is true? Okay, is this function increasing? Like, is as the heights are getting bigger, is the volume getting bigger? Yes. And then to check to see if it's increasing by a common factor, you would take this number and divide it by the previous. And you do get 1.6 there, but let's keep checking. We take 504 and divide it by the previous. You get 1.5. And then I think it starts getting off by a lot more than that. And then it's 1.4. So I would say it's not a common factor because it's kept getting different things. So if the function is increasing, we're not going to choose that the function is decreasing. All right, and then the function is not linear. If it was linear, you would be adding the same thing each time. And so for that one, that's adding 126. And then if I take 336 and add 126 to it, it's not adding the same thing again. So that is true. It is not linear. All right, and then the maximum value of the function is 100 or 1,320. All right, so because the maximum height is going to be 10 inches, that should be the maximum volume also. Because they don't have any bigger prisms or bigger boxes. Right. And then on number 12. This graph shows the height in meters of a rocket X seconds after it's launched. And so we want to know, I don't know, it says white. I guess it should say which statements accurately describe the function h of x. Okay, the graph goes from increasing to decreasing. What do y'all think? Yeah, it's going up. The rocket's increasing in height. And once it gets to this maximum, it starts decreasing in height. So that's true. This one is very, very tricky. The range is from 4 to 22. Is 4 meters the lowest it goes? It is not. It's technically 0. It hits the ground at 0. So B is not true. All right, the rocket is in the air for 4 seconds. What do y'all think? What time does it hit the ground? Yeah, it hits the ground at 4 seconds, so that is true. The rocket reaches a maximum height of 22. Yes, that is true. And the rocket travels a greater distance upward than downward. What do y'all think? That should be false because it goes upward from 4 feet to 22 feet and downward 22 to 0. So that is not true. All right, we're going to go through all this in one day. Okay, and then for 13, Tim went on a run 3 consecutive days. On day 1, he ran a sixth of a mile. Day 2, a quarter, or 16th, sorry, and then a quarter, and then 1 mile. He continues this pattern for 2 more consecutive days. We're going to write an expression to represent the distance he traveled. Okay, so you guys should have, thank you, a reference sheet that we want the sum trying to remember this off the top of my head. Yes. Okay. So R is going to be what we're multiplying by each time. Do you guys know what that is? What R is? It's okay. If you don't, you can take one of the terms, like the second term, and divide it by the previous term. And so R is going to be 4. We're multiplying by 4 each time. All right. I can kind of already see what it is. They have their order different than ours, though, but it's not going to end up mattering in the long run. So if R is 4 and A sub 1 is the first term, which is 1/16th, which choice do you guys think it is? Even though the 1 and the R are switched. Can you guys tell? If we're using this formula right here, but maybe these two are switched because that doesn't really matter in the long run, it's going to be B. Don't really like that they switched the R and the 1 because on the reference sheet they have it one way. They should keep it that way, I think. That's okay. Okay, a couple more. So the value of a motorcycle each year follows that sequence. Which formula represents the recursive definition of the sequence where n represents the number of years? Okay, so we need to figure out how much this is dropping each time. All right, so it's dropping by $2,400. Okay. In recursive sequences, use the previous term, and a sub n minus 1 means the previous term. Let me double check on that subtracting, because I actually could be wrong here. Yeah, I definitely am. Just kidding. It's not going down by 2,400. So I'm going to take 1. I'm going to divide by the previous one, and I got 0.8. Let me see if that happens again. Yes. So we're multiplying by 0.8 each time. So we're going to take the previous term and multiply by 0.8. And the previous term is a sub n minus 1. So that's going to be choice A. All right, and the number 15 is easy to get wrong because there's two choices that graph very similarly. And so you need to check like where the height it is on the axis, but you also need to check where it crosses the x-axis right here, that it is at 2. So the two that are similar are B and C, I'm pretty sure. So here's B. And if you look at B, it crosses the x-axis at 1, but we want it to cross the x-axis at 2. So I didn't put it in wrong. I put it in B. I put it in B.
You put +2 or +3.
Oh, I did put it in wrong. Sorry. Okay, that one crosses that 2. The other one probably crossed somewhere close to 1, but not exactly 1.
How can we know?
What?
We know.
I mean, I can go back and show you that it's not right, but the one I just typed in was C, and it's perfect. You can see it crosses at 2. It looks very similar.
It's called steady progression.
All right, it still looks like it crosses at 1. It might. It's wrong though. C is right.
I got